So today's lesson 4.1, starting chapter 4, and we're going to continue with our work with equations, as we will in much of algebra. And we're going to be using those equations that we've been kind of learning how to solve, learning how to algebraically manipulate both sides, and apply them specifically to percent problems. So some of this will seem familiar. We've definitely covered percents before, but now we're going to specifically apply it to the work we've been doing. So the big idea today, many types of questions involving percents can be answered by solving an equation in the form a times x equals b. So this is a one-step equation, and if we can set it up correctly, it's pretty simple to solve. So a percent is a number times 1 over 100, or more importantly, per 100. So we know when we get a test grade, maybe the test was out of 20 and you got 17 out of 20, but what percent is that out of 100? And that's what a percent is always going to tell you, is how much per 100 or compared to 100. We're also going to talk about markups and discounts. So if an item is discounted some percent, you pay 100 minus that percent of the original listed price. For instance, if an item is 30% off, 100 minus 30 is 70. You're paying 70% of the price if it's 30% off. And the opposite is true. If an item is marked up or taxed, you're going to pay 100 plus that amount of the original listed price. So if there's a 6% sales tax, 100 plus 6, you're paying 106% of the price. Now, we are going to kind of walk through some basic ones, and then we'll start looking at some word problems and try and take this a step further. But for these ones where they're specifically just giving you basically the numbers and there's no real life problem associated with it, we're going to set them all up pretty much the same. So the first thing we want to make sure is we know that 7% and 70% look different when we turn them into decimals. Now, you can physically go ahead and divide them in your calculator by 100 because we're comparing it to 100. So if you take a look, 7 divided by 100 is 0.07. And if you did 70 divided by 100, that's 0.7. So we're going to have to turn these to decimals. And so we always want to make sure that we understand a 1-digit percent has to have this 0 here, and a regular 2-digit percent can just be written as 0.7 or 0.70 if you want to add the 0. So we always want to make sure that we don't express 7% as 0.7, because that's obviously a big difference between 7% and 70%. All right, so when we write these, we're going to kind of just walk through it word for word and translate it. So when I see 7%, I'm going to write 0.07. Then it says of what number. When you want to find the percent of a number, you're multiplying. So when I see this word of, I'm going to show multiplication. It says what number. Now that's what we don't know. So that's going to be our variable. Let's put x in there. And when I see the word is, I'm going to write equals 91. So 7% of something, if I multiplied and found 7% of some number, it's going to give me, or is, 91. So if you notice what I just did, I translated this. We want to make sure we understand of is going to be our multiplication, and is equals. Makes sense. So whenever you want to find the percent of a number, you're going to multiply. So now we want to solve this simple equation. I want to get x by itself. I want this to say x equals, and then I have my number. So what am I going to do? I'm going to divide by 0.07 so that it cancels out. And so 91 divided by 0.07 is 1,300. So 7% of 1,300 is 91. So if I were to take 0.07 and multiply it by 1,300, that's how I would find 7% of it. If you take a look, it's 91. So I know I did it right. So let's try number 2. We're going to use the same equation to set it up, but we're going to have a different place for our variable. So it says what percent. So here's your percent. Call it x because we don't know what it is. What percent of means set up your multiplication. 160 is equals 38.4. So If we knew the percent, we would multiply it times 160, and that percent of 160 is 384. What percent of 160 is 384? So now we can solve this. We want to get x by itself. So we're going to divide 38.4 divided by 160. And here's what we get. So x equals 0.24. Now we can't stop there. It says what percent? 0.24 is not the percent. We need to translate that into a percent, just like we did up here. Now you technically can take it and times it by 100, and it'll tell you. But if you recognize that you're just going to move it 2 decimal places, 0.24, your answer here is 24%. So if I took 24% of 160, it should be 38.4. So if I did 0.24 times 160, I get the 38.4. All right, the only other spot the variable can be now is all the way at the other end. So what number, I'm going to put x when I see what, is, I'm going to put equals 62%. You got to write it as a decimal, so 0.62 of, set up your multiplication, 980. So we're going to take 62% of 980, and we want to know what that is. So it's kind of written a little bit backwards. Before, the place that the x is in was actually on the right side, but the way this sentence was written, they put it on the left side. But it doesn't matter. You could have wrote equals x over here. They could have said 62% of 980 is what number, and then you'd have the equals over here. So that doesn't matter. We know that an equation can be written either direction, so that's fine, no big deal. Now we don't need to divide by anything on this one because we're not trying to get x by itself. It's already by itself. So all we need to do is find the final answer. Find out what is 62% of 980. So 0.62 times 980. And our answer is 607.6. All right, once you get the hang of these, they're very straightforward. Just kind of set them up in the same order. Your percent times the number is something. All right, now let's apply this to some real life situations. So example 4, a dishwasher normally sells for $320, but it's on sale, so it's going to be cheaper, for 15% off. What is the sale price? So they can ask you a couple questions here. They could ask you how much are you going to save, or they can ask you what's the new price. All right, those are the 2 basic questions that they're going to ask. So you always need to make sure you're actually answering the correct question first of all. So it normally sells for $320. It's 15% off. So we want to find out what's 15% of $320. Now there's 2 ways to do this. So we're going to set them both up. Option 1, option 2. So option 1 would be to find 15% of $320. And since it's a sale, we're going to take it off the price. So we're going to take $320 and we're going to times it by 0.15. And that's going to tell us what 15% of $320 is. So $320 times 0.15. Gets me 48. Now, if this was a multiple choice test, an SAT, an M-STEP, whatever, I guarantee you this will be one of the answers. And as soon as you multiplied and you saw this, and then you look up and you see the answer, you're going to be likely to choose it. So you got to be careful. That would be incorrect. We're not done. So it's $320. We're getting 15% off. We just found out that 15% is $48. That's what's coming off the price. So now they want to know how much does it cost you now. So just think about it regularly. If it's $320 and now it costs $48, that would be a huge sale. It's only 15% off. So that's a nice sale, but it's not going to go from $320 to $48. $48 is what's coming off the price. So we need to take $320. We need to minus the $48. That's what's coming off. So our final sale price, and let's write it down so you know what you did. $320 minus $48 is $272. Now, option 2 is to kind of think about it like we had on the big idea on the back. If you're taking 15% off the item, that means you're paying 100 minus 15%. So if you take 100 minus 15%, that's going to equal 85%. So if 15% is coming off the price, you are paying 85% of the price. So instead of doing this in 2 steps, we can do this in 1. Instead of taking 15% and subtracting it, I can just find out what is 85% of 320, and that's what I'm going to be paying. So let's see what happens. 320 times 0.85 is 272. And if you take a look, that's the same answer in both spots. Okay, so it doesn't matter which way you do it. They both make sense. Okay, this one's one more step, but that doesn't mean it's incorrect. Okay, or that one's better than the other. So whichever way makes more sense to you, that's the way you should attack it. All right, example number 5. Now we're going to go the other direction. Instead of a sale, we're going to mark things up. So a store owner buys a television from the manufacturer, and then he adds 45% of that cost to get the price the consumer pays. If a TV sells for $4.99, what did the store owner pay for it? So obviously, when you own a store, you're trying to make money. So you buy a television from the manufacturer, and then you have to mark it up so that you can make some money. Now, he marked it up 45%. The big mistake people want to make here is they're going to just take the $4.99, find 45% of it, and subtract it off to try and get back to the price. Here's the problem. 45% of this is different than 45% of the original cost. This is going to be a bigger number than what he paid. And 45% of this is going to be more than 45% of that smaller number. So we can't just take that off. It's going to be a different amount. So here's how we need to think about it. They had the original cost, right? X. And then he added 45% of X. And he got $4.99. So it was his original cost. Let's just take a guess. Let's say it was $400, right? And then he added a certain amount, maybe 99, to that. And that number represents 45% of whatever it was. So if this number was 400, we'd do 400 times 0.45. So let's just try it. 400 times 0.45. We would have got 180 at that point. Okay, so we would have had 400 plus 180. So that's obviously not correct. But this 180 would represent the 45% of it because I took the price, I times it by 0.45, and I added them together to get this. So that's incorrect. So how do we actually solve this? Well, let's say we wanted to just use our algebra to get this done. This is a 1x and a 0.45x. So if I combine them, it's 1.45x. Think about what this represents. This is 145%. If you take 1.45 and times it by 100, it's 145%. So as soon as we start going over 100%, people get confused. But think about it. The price that the company paid for the television to begin with, that's 100%. And then he adds another 45%. So if you add 45 to 100, you have 145%. And that's what the consumer pays. Okay, and then the owner has to either pay it up front or pay back the 100%, but then he gets to make the extra 45%. But you, the consumer, are paying 145% of the price. So let's find out what it is. All I have to do now is divide by 1.45, and I've got my answer. X is by itself. X represents the original cost. So $4.99 divided by 1.45 gives me this. Okay, now we're going to have to round that. We've talked about leaving numbers the way they are, but this is a real life problem. This represents a dollar amount. So we do need to round this to the nearest cent. So you've got your dollars and cents are expressed into the hundredths place, 2 decimal places. So we're going to look at the first number that we're not using, the 7, and that tells us if it's 5 or higher to bump this up 1 cent. So our final answer here is going to be $344.14. Okay, so that was the price that the owner paid for the television. He added 45% of this. So if we took this and multiplied by 0.45, that would give us 45% of this, and then tacked it on to get the $4.99 that the consumer is going to pay. So be careful. Everybody wants to take $4.99 and times it by 0.45. Let's see what would happen if we did that. $4.99 times 0.45 is $224.55. Okay, let's write that down for a second so we can see what would happen if I thought that that was what was tacked on the price. So if I took the $4.99 and I minused $224, I get back to this. Take a look at the difference. All right, if I take 45% of $4.99 and take it off, you're telling me the price was $274.45, but the actual price was $344.14. So you can see it's not even close. Okay, so be very careful. Don't take 45% of this number, because that's very different than 45% of the original number. Okay, so we got to work our way backwards. You're paying 145%.